take a look at the second derivative test. The second derivative test says that f of x be a function such that the second derivative is continuous over an interval containing c, and that f prime at c is equal to 0. If the second derivative at z is greater than 0, then f of x has a local minimum. Recall that f prime at c being greater than 0 refers to the function being concave up. Let's note that. So this is the instance where the function is concave up, and therefore there is a local minimum. If f double prime at c is negative, then f of x has a local maximum. This f double prime of c being negative is the case where the function is concave down. Lastly, if the second derivative at c is 0, then we basically can't tell. So let's take a look at a couple of graphs. So here we have a function that is concave up. You'll notice that if we consider the tangent lines to the curve, that the slope of those tangent lines are increasing. So this is a concave up function, and there is a point C right about here, such that f prime at c is equal to 0. So I have a function that is concave up, or the second derivative is positive, and the first derivative at c is equal to 0, and my function, if I were to find its second derivative, would be continuous. So we can see here that the presence of a local minimum at c would make some sense. So here we have a second function that is concave down on approximately the interval that I'm indicating on the x-axis. So this function is concave down on essentially that interval. Notice there is a location where the second derivative is equal to 0. There is a c where f prime at c is equal to 0. Because the function is concave down on the indicated interval, we know the second derivative is negative. We have addressed this issue of f prime of c being 0, and we can see based on the behavior on the graph that if we have a place where the derivative is equal to 0 and the function is concave down, we should expect a local maximum at that point. So let's look at a quick example of using the second derivative test to find the relative extrema of the function f of x equals x cubed minus 6x squared. So to use the second derivative test, we need both the first derivative. So our first derivative is 3x squared minus 12x, and we need the second derivative, which is 6x minus 12. What do we use the first derivative for? We use it to find the zeros of the derivative. So we want to know where 3x squared minus 12x equals 0. Factoring out a 3x, we get 3x times x minus 4 equals 0. And so 3x equals 0 at x equals 0, and 3x x minus 4 equals 0 when x is equal to 4. So we have two potential locations where this there is a maximum or a minimum. Now, to use the second derivative test, we simply evaluate the second derivative at those points. So what is the second derivative at 0? It is 6 times 0 minus 12. And we just need to know the sign, and this is a negative value. And because that's negative, we know that the function is concave down, which implies, so concave down, which implies that there is a relative max. And then for our second 0 of the derivative, f prime at 4, double prime at 4, we get 6 times 4 minus 12, which is 24 minus 12. 24 is certainly bigger than 12, so this will be a positive value. Because that is positive, we know that the function is concave up at x equals 4, which implies there is a relative minimum at x equals 4. So let's go ahead and find the corresponding y values for x equals 0 and x equals 4. F at 0 is equal to 0 cubed minus 6 times 0 squared, which is going to give us 0. F at 4 is equal to 4 cubed minus 6 times 4 squared, which if we simplify is equal to negative 32. Now, we use the second derivative test to determine this information, so we're going to say that in our explanation or our answer. So we say by the second derivative test, f of x has a, now let's do the relative maximum first. So at x equals 0, we have a relative maximum, and that maximum value is 0. So it has a relative maximum of 0, relative maximum of 0 at x equals 0, and a relative minimum. Okay, so relative minimum, that happened at x equals 4, and that minimum value was negative 32. So of negative 32 at x equals 4. I hope you find this helpful.